In this video, we're going to solve question 38 of 2021 Junior Mathematics Olympiad first round. Question goes like this. Which of the following will always be an odd number for all possible integral values of n? And then we'll have our 5 options. So for this question, if we're able to find a value of n that's when plugged into any of these options will give an even number, then we can conclude that that option is not correct, right? Okay, so let's look at this first option here. So we'll have 5n plus 1. So if n is 0, for example, the sum will be 1, which is odd. But then if n is 1, this sum is going to be 6, which is even. So we can say that option A is not the answer, right? So A is not the answer. So a better explanation for this will be that when n is odd in general, let them write 5n plus 1 here again. So we have this sum 5n plus 1. And when n is odd, this product here will be a product of an odd number and another odd number. So it will still be odd. So this product here will be odd when n is odd. And notice that we're going to add 1 to it at the end, right? And so 5n plus 1 is now going to be an odd number. That's 5n plus 1. And an odd number plus 1 will be an even number. So whenever n is odd, 5n plus 1 will be even. So that's why 5n plus 1 is not an odd number, or will not be an odd number for all integral values of n. So 5n plus 1 is out of the way. Let's look at this second one. Oh no, B is actually the answer. So let's just look at why C and D and the rest are not the answer. Okay, C. Let's look at C. So C is 5n minus 1. When n is 0, it will be minus 1, which is odd, yes. But when n is 1, 5n plus 1 will be 4, which is even, right? So we can conclude that C is not the answer to this question. A better explanation for this will be that when n is even, or whenever for odd n, 5n minus 1 will be even. So if n is odd, or if you plug in an odd value for n here, 5n too is going to be a product of an odd number and another odd number, which will still be odd. So 5n will be odd. And then when you subtract 1, it's going to be an odd number minus 1, which is going to become an even number. So that's why I can say that 5n minus 1 will not be an odd number for all integral values of n. Because here we just showed that whenever n is odd, 5n minus 1 will be even. Then for this third one here, we have n squared plus 2n plus 3. So n squared plus 2n plus 3. So this one is an interesting case. So when n is 0 here, the sum is going to be, or n squared plus 2n plus 3 is going to be 0 squared plus 2 times 0 plus 3, which is just 3. But which is odd, right? But when n is 1, this will be 1 plus 2 plus 3, which is 6, which is even. So we can say that D is not the answer. A better explanation for this would be to say that when n is odd, the value you have in D will be even. Let's talk about that. So we have n squared plus 2n plus 3. So when n is odd, n squared is also going to be odd, and 2n will be even since we have 2 already here. So it doesn't even matter whether n is odd or even. 2n will be even. And then we'll have 3, an odd number here. So this expression, n squared plus 2n plus 3, is going to be the sum of an odd number, an even number, and another odd number, which is going to be an even number. So that means that whenever n is odd, right, n squared plus 2n plus 3 is going to be even. So that's like the explanation for why D is not the answer. So on the question, D and option B and E, or option B appeared twice. It also appeared as option E. So I just wrote it here so it will match what we have on the actual questions. Okay, let's talk about why B now will always be odd. So when n is 0, for example, the value of 6n squared plus 1 is going to be 6 times 0 squared plus 1, which is just 1. When n is 1, the value of 6n squared plus 1 will be 6 times 1 squared plus 1, which will be 7. When n is 2, the value of 6n squared plus 1 will be 6 times 2 squared plus 1, which will be 25, which is also odd. So the reason why 6n squared plus 1 will always be odd is because regardless of the parity of n, regardless of whether n is even or odd, this sum here, 6n squared, is going to be even. The reason is because we have an even number multiplying n squared, and an even number times any number, regardless of its parity, is going to be even. So for any number we choose, 6n squared will be even. And then when we add 1, we're going to end up with a number that is going to be odd. So that's the reason why 6n squared plus 1 is going to be odd for all integral values of n. So option B, or if you prefer to choose that, is the correct answer. That's how to go about solving this question.